and then the girls are gonna do this big one first, and then they're gonna do these two other sorting algorithms. So I'm gonna have you guys come up and do it in a second, but talk to them about how this one here, A, is faster than B. For example, in A, in B, you're comparing one at a time. So you're doing things in serial manner instead of doing it in parallel. So, you know, a lot of girls hear about like Intel has parallel processing, but they have no idea what that actually means, for example. So just sort of encourage them to think about those things. Talk to the girls about computer programming projects that you have done in school or in your work, for example. A lot of times, you know, there's this program through a nonprofit in downtown LA that actually teaches girls how to program an Android app. And they do that with the Google app developer. So it's really, you don't code at all. You're actually using Lego, it looks like little Lego pieces and you pull it over and make a software. And yeah, but like Scratch from MIT. They don't notice that you don't have to sit on the computer and do like semicolon / / you know, that you don't have to do program that way. So if you have experience working in a different programming language that's visual, for example, you can talk to the girls about that.
I've had to break their brain, introduce them to Lisp.
Well, there's probably, if you have time on the day of, you can do that. But so I'm going to leave these four out here, these two algorithms. If you guys want to come up, I'm going to give you guys a group of random numbers. If 4 people at a time want to come up and try it.
And you said that these are not actually going to be there. We're going to draw those on the floor, or they're the materials there?
It's going to come like this to you. So it would have been pre-drawn, so you just have to spread it up.
Just to put it
Yeah.
lay it out.
Yeah. So you're going to get 3 of these, the big one and then these 2. You want us to try it out? Or? Yeah, come on over and try it out. So you're also going to get a little timer, so if you really want to time them to see which one goes faster for the girls, if you have 4 people lined up here, here's numbers.
Is this an outdoor activity, or it's going to actually be?
I think it's going to be in a classroom setting.
Classroom setting.
Yeah. All right. So you're going to move up to the X.
No.
And at each node, you're going to compare your numbers. You two are going to compare. And then the larger number stays to the right, and then the lower number goes towards the left. Okay. And then, yeah, and then you're going to compare the next node again. You're going to compare. Yeah, and then you guys are going to compare. Okay, so can you number? 10? 10?
99, 100, 112.
So if another 4 people want to come and try together, like this.
So lower to the left, higher to the right?
Yes. So we need one more volley. What's that one?
All right.
Alright, so 2 people are going to move up to the node.
Up to this?
Yeah, up to this node. The X is the node. Alright, sorry. And then you guys are going to compare.
Bigger to the right?
Yeah. You're going to come all the way over here. You're going to move up here. Now you're going to move up there.
Bigger to the right?
Yeah. So you're going to go here. That's where you're going. Oops. Right? Yeah. And you're going to meet her there. So you guys are going to compare. You two. Yeah. You're moving up here. Yeah.
Oh, okay.
Oh, no, you're right. Yeah, right there. And then you guys are going to compare.
So I go here and I go all the way
Up
up
here.
here.
Yeah. Then you guys compare.
We compare.
Okay.
8, 11, 15, 99.
So at the end of each module, they sort of have these closing questions you should bring up to the girls. So some of it's like, what's your dream job? Like, what about it makes it your dream job? And So and another question is, if you were a product designer or a computer scientist, what problem would you like to solve? A problem that you see today, what would you like to improve, for example? And what skills do you think you will need to develop to become a product designer or a computer scientist? And then, so one of the things about the journey books that they'll be getting is they can discover real problems that girls and women face and think about how science can help them. I don't know if anybody's been to the Skirball Museum recently. They have an exhibit called Women Lift Up Half the Sky. It's an exhibit based off of Nicholas Kristof, the editor from New York Times, and it's really about how women solve problems in third world countries. So one of the great examples is this woman in Africa always used to have to walk like 15 miles every day to get water in a bucket, for example. But she developed this little roller, so she can roll it like a wheel, but it holds water in. So it's it requires a lot less energy. She doesn't spill. She can save a lot more time doing it. So there's a whole exhibit about that, for example. So have girls think about those things.
There's just an interesting thing that you can use. Women tend to change the way we use technology, and they said a good example is the phone. When it first came out for public use, they used to release these little placards that said how to use it because it was for business only, and they found that the wives and sisters were using it to call their moms. So they released these things saying, never use it for personal calls. If you're going to use it for personal calls, limit it to 5 minutes, because that phone was for business. And nowadays, personal calls are the majority of the phone's business because women found that way to use it that men had never considered. Why would you want to?
We're going to go to the next module. So, Lily, can you have somebody fold these up whenever you get to? So in this module, it's called Imagine Yourself in a Lab. The girls are going to be forensic scientists and a biochemist and a food scientist. So before you start this session, the girls are actually going to use alcohol to separate the DNA out of the banana. So make sure the alcohol is on ice. So make sure it's cold because it works much better. So we're actually not going to do the activities from this module, but I'll sort of go through them so you guys have an idea. So the first icebreaker that you're going to do with the girls is ask the girls, what can you find in a lab? Like, most of the girls, if they've never been to a lab, they think of lab as like what they see on CSI, for example. Like, what do you see there? Like, I always think it's funny, they always show people pipetting. Like, it's like that's the most important skill you'll learn as a scientist, but I guess that it requires some, hand-eye coordination, but, ask them what do they see, what kind of, they see like those rotating DNA separate, like just ask them to think about it. And then ask them, like, have they seen any forensic TV shows? And how do CSI solve crime? It's really, they use science to solve crime. They look at the evidence, they analyze it, and then they use that to solve a crime, for example. And then think about, like, what are some of the things that you think was discovered in a lab? So one of the examples I love to tell people is that I have a friend who's a chemist by training, and what he does is develop potato chip flavoring. Like, he makes like different kinds of barbecue seasoning that goes on the potato chip, for example. That's all discovered in a lab. Like jelly beans were discovered, with the technology to sugarcoat those were discovered in a lab, for example. And the next thing you're going to do is you're going to set up this little cup puzzle. So you're going to have 6 cups, and 3 of the cups are going to be full. And your challenge is you're going to rearrange these cups so that it is alternating. Full, unfull, full, unfull, for example. You can only touch one cup. Okay. So you're going to give the girls some time to think about it, and you're going to ask the girls to come up and try it.
Are you just talking about, like, you take one of the cups and pour it into another? Like,
you could do that.
If you do 4 and then pour it into one,
Yep.
then it alternates?
Yep. So, but sometimes girls don't think of, when you say just touch one cup, they don't think that you can pour, for example. Sometimes the scientific guideline you give them, they can go, when it says you can touch, it didn't restrict them from pouring, for example. So that is a way to encourage them that you can think outside the box to do so, but you're exactly right. So you can set that up in the front desk and have one of the girls come up and do it. So the next activity they're going to do is they're going to extract DNA from a banana. Is anybody? So what is a DNA? So girls have probably heard about DNA, but they don't, DNA really stores our genetic information. And everyone's DNA is unique, and you can access information through sequencing of that DNA. And today, like many startups companies aim to make sequencing affordable. So people have already, sequenced the entire human genome, for example. Right now, it costs about $10,000. And I can name you like hundreds of startup companies in the Bay Area that their goal is to make it cost only $100. So that, so that we understand our genetic information, and then so that we can, prepare ourselves for, if I have the BRCA gene, for example, and I may get breast cancer, I can probably figure out a prevention method or be more persistent about screening, for example. So reducing that cost, and this is a really an active field of research going on today. And we can learn about important health-related information from our DNA, and then one day we might be able to use genetic therapy to fight disease. So at the moment, we don't have a way of fixing our mutations, for example, in our genome that has like a mutation that causes a disease. But that is something that a lot of science needs to be done, that we can develop genetic therapy. So something that that I personally try to get the girls to understand is that science is constantly evolving. Just because now we know how to sequence DNA does not mean that we already know everything we need to know. Now we need to figure out a way to how to fix those little mutations that exist, for example. So encourage them to see that it's evolving. They can contribute. Sometimes they feel like, oh, everybody knows everything about the solar system, like there's nothing for us to learn. But encourage them to see that there's more of that. So what is the DNA used for? It's used to solve crime, it studies diseases, it modifies organisms like food. Like practically everything we eat has been in some way genetically been modified. Apples are made to be sweeter. Grapefruits are genetically mutated to make it bigger. Produce more yield. And you can also use DNA to trace ancestry. There's a lot of TV shows about that. You use your DNA information to see where you come from, for example. You can study DNA as a biologist, chemist, a physicist, bioengineer, geophysicist, food nutritionist. So people who are interested in studying DNA can really go into a lot of different fields of science. So when you lead this activity, you're going to follow page 22 in your guide. So I'm not going to go through it step by step, but these are just some of the keys that I wanted you to be able to lead. So when you're going to mash the bananas down, you want to make sure it doesn't form any air bubbles in the little Ziploc bag. And you're going to tell the girls that they're going to add salt, which is going to bring the DNA strands together. So you're cross-linking them so you can separate out. This will make a lot more sense when you guys do it with the girls. It's pretty simple. They mash the banana, they put some alcohol and salt, and then they start to see the DNA separate out. You're going to encourage them to make observations in their lab notebooks because, as a scientist, one of the first things I didn't learn as my first year in grad school, I didn't really take lab notes. I was like, oh, I'll remember how to do this. And then 6 years later, when you're writing your thesis, I'm like, shoot, what did I add? So, really recording things is an important habit that scientists should have. And then alcohol is going to help precipitate the DNA out. And so one thing you should talk about is that, talk to the girls about human DNA is, it's about 6 times longer than the banana DNA. Banana has so many sequences. In your book, actually, there's a little, 23 gives you an example of where DNA comes from. So there's some cute insights that you should talk to the girls about. This is a page that the girls will not have. It's only for you, so then you can talk to the girls about it. And one thing that also you should tell the girls, you don't have to sequence the entire genome to get information. Sometimes you can just look for certain sequences. So when women have breast cancer, for example, they always screen for BRCA genes. And they don't sequence the whole genome because it's so expensive. So you just look for where those segments are. And even from those little segments, you can get a lot of information. So they're going to make a salad dressing. A lot of us probably have made salad dressing at home with vinegar and olive oil, and we put a little mustard or egg to emulsify. So they're going to be doing that themselves, and they're going to try to develop different flavors, and they're going to judge whichever ones they like best. So what does a food scientist do? They develop recipes and develop new cooking techniques. Another thing that you do as a food scientist is you develop flavoring for potato chips, for example, I was talking to you about, but they also develop new foods. We see all these different sugar substitutes, for example, that keep coming out. There used to be Splenda, sweet and low, all these things. A scientist somewhere just developed those things. Or even fat-free milk, because milk that comes out of the cow has fat. Developing a way to separate that fat out is, a scientist was involved, a food scientist was involved in that. So four girls are going to be in one group, and a pair of them are going to develop one recipe. They're going to have them pick which one tastes best, and then 6 or 7 recipes from that room is going to come up, and the girls are going to do a tasting with bread, or they're going to do bread, right? And they're going to figure out which one they think tastes the best. So one thing that you have to encourage them to do is make sure they write down their recipe when they're developing it. I'm not very good at following recipes. I just pinch this, pinch of this, but that's not a very good reproducible recipe, for example. So have them, they put a half tablespoon of salt or sugar in, make sure they write that down. Have them think about how they will market that product, for example. What would you call it? What kind of salad dressing would you want it to be called? And who would you market it to? Like, it will be marketed towards kids if it's a sweeter end, for example. Think about those things. Have the girls think about those things. And have them compare their ingredients to what's in a commercial product. So there should be a commercial, like a thing that you can buy at a grocery store. Salad dressing is going to be there. And most likely there's going to be ingredients in there that girls can't even pronunciate, a lot of preservatives or things to make sure that the salad dressing doesn't separate. When you make a salad dressing at home, a lot of times it separates if you leave it in your refrigerator. But when you buy commercial from Kraft or something, you see that it doesn't separate. So they usually add chemicals in there to make sure that that doesn't happen. But are those chemicals natural? Like, is that something that we should be, people say if you can't pronounce what's in the ingredient list, you shouldn't get it. But that means you can't eat anything that we have at the grocery store nowadays. But just have the girls see that what they made is really olive oil, with vinegar, oregano. These are all things that they can, they know what it is in there.
So you'll have commercial products there as well?
Yeah. So it'll be there so they can see the ingredient list. And then the girls are really making a emulsion. So, do I have that slide? So on page 29 of your book, it actually talks about water and oil immersion and oil and water. It talks about which one is more stable. So in the case of lettuce leaves, you really want it to be oil and water because lettuce leaves are more oil permeable. So the outside molecule should be water so it doesn't just go through the cell structure of the lettuce, for example. But you can definitely use this diagram as sort of like a guideline to explain those to them. So then let's see. Well, one of the things that these are just some tips that you should give the girls is that they should add the oil really slowly when they're making the emulsion, for example. If you just pour all of it at once, it's really hard to emulsify it. And then encourage them to do a blind tasting so that they don't know which one they're picking because bias gets introduced. And if it's not emulsifying, what might have gone wrong and how would you fix it? Should you add more oil, add more mustard? That helps make the emulsion. Some of the closing questions you should ask is, what do you like to do, and how can you turn that into a job in a lab? Some girls may say they really like learning about different fossils, for example. But how do you relate that to a lab job? And what kind of education do you think you will need to work in a lab? Not everybody has to, you can talk about there are different types of science you should study, or a lot of people. I actually met a lot of students who are in high school and they want to be a forensic scientist, but they really want to do it in the criminal side. So they go to tech schools to learn how to become a tech at a criminal lab, for example. To work in a lab and do science research, ethics is very important. That's something that sometimes scientists lack themselves, and you must be open to discussing your methods, and you have to share it as a scientist. You got to make sure that your data are reproducible. I should say data, not date. Sorry about that. And you must be able to present your data in an honest fashion. You can't skew it to fit whatever hypothesis you want it to fit to. So in the leadership journey that the girls will get, they're going to talk a lot about good ethics. So it's not just that, because a lot of times when you do an experiment in your lab, nobody else is watching over your shoulder. But they really trust that you wrote down exactly what you did and how it went wrong and how it did work. So in science, it's a very open process, and then girls and any scientist has to have good ethics to become a good scientist. So these leadership journeys that they're going to get is going to talk about those things about having good ethical decision-making process. So in the next module, which you guys are going to do, So they're gonna be electrical engineers. So they're gonna make a little buzzer and use that to play a game show. So they're gonna make a circuit, for example. So the icebreaker they're gonna do is, they're gonna talk about what they know about electrical engineering so far. A lot of people don't really know what an electrical engineer does. So you're gonna ask like, what do you think an electrical engineer does? A lot of kids will say, oh, they put like power lines down. They think of like these like big structural things. They build a power plant, for example, which is probably some, that's more like civil or mechanical engineers, but like they don't know what an electrical engineer does. So they usually develop and design complex electrical systems that power our lives. For example, probably a lot of electrical engineers studies the electric grid, and see where we have shorts, and figure out how to fix that, how to prevent blackouts, for example. So the girls are first going to talk about, learn about how a circuit works. So your question to them will be, what is a circuit? A lot of, at the age of high school, they should know what a circuit is, but they may have never built one themselves. So the first thing they're going to do is they're going to make a human circuit. So a little group of girls are going to get together and connect themselves into a circuit, because the circuit is never complete if it's not completed. The other end doesn't complete. So you're going to assign each girl to a different component: a battery, a wire, a conductor, buzzer, a light, and a switch. So you're going to pass the ping pong ball around from the battery to the next, and you're going to travel it around. So when it hits a light, the girl's going to try to pretend like they lit up. They pass through the buzzer when the electron from the ping pong ball travels through. They're going to make a noise, like the buzzer makes a noise. And then have them try to do it faster and faster. And then at some point, most likely, somebody's going to drop the ping pong ball. And that is an example of a circuit that's been shorted, for example. So you can talk about those things while they do that.